So in order to draw orbital diagrams, we need to know a couple of things. So let's look at this problem. Draw the orbital diagram of indium. First of all, it's important that we're going to draw the orbitals. We have to write them out in the order of their energy. Also, it's important to know a couple of things. The quantities, we have to have the proper quantities. For S, it's going to be just 1. For p-type orbitals, it's going to be a set of 3. For d-type orbitals, it's going to be a set of 5. So let's go ahead and begin. It doesn't really matter whether we're doing indium or any other element. We need to start with our orbitals in the proper order. So let's just draw them out. I'm going to do them horizontally. We have 1s, then 2s, 2p, because it's p, it's going to be a set of 3 orbitals, 3s, 3p is a set of 3 orbitals. Remember that in energy, the 4s comes next. Then we go back and have the 3d. And that's a set of 5 because they're d orbitals. I'm going to continue on to the next line. After 3d comes, in energy, comes 4p. Then the 5s. Then the 4d. Then the 5p. Then the 6s. Okay, now let's go back to the original problem. That's going to be the same regardless of which element I'm doing. When this problem is asking for indium, when I look up indium on the periodic table, it has an atomic number of 49 protons. That means it also, if it's neutral atom, has 49 electrons. So I have 49 electrons to put in these orbitals. Recall that each orbital in a particular sublevel is going to get 1 electron before we begin to pair them up. So as we're filling the p's and the d-type orbitals, we're going to put 1 in each orbital and then go back and pair them up. So now I just count up to 49. So starting at the 1s, we have 1, 2. Then 2s is 3, 4. Moving on to the 2p, again, we're going to just put 1 in each orbital. 5, 6, 7, 8, 9, 10. Now they're paired up. So I have a total of 10. Sometimes I like to kind of keep track of how many I've got so I don't lose count. Moving to the 3s, 11, 12, 3p, 13, 14, 15, 16, 17, 18. 4s is 19, 20. Kind of keep track that I'm up to 20. 21, 22, 23, 24, 25, begin to pair up. 26, 27, 28, 29, 30. Moving on to 4p, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. So I'm up to 48. I have 1 more left. That'll go into the first 5p orbital. I can do some checks here. By the way, I don't need the 6s. At this point, I could just erase that. But I didn't know whether I was going to need it or not, and I won't till the end. So at the end, you can go ahead and clean that up. So to check this out, notice that I can use the periodic table and the blocks on the periodic table. Indium on the periodic table is in the 5th period. And it's in the first seat to the left of the P block. And that means I'm expecting that the final subshell should be 5 for the 5th period, should be P because it's in the P block, and it should be 1 because it's in the first seat. And sure enough, when I look at the my orbital diagram, I have 1 electron in the 5p block. So this would be 5p1. So it's a good check if I want to use the periodic table positioning to check my orbital diagrams.